Let me do this integral by 4 different methods. And through these 4 methods, I would like to discuss here in general, how do we do this kind of integral in general. Now here I'm talking about the method is basic integration method. It's not no Feynman trick, no Cauchy's residue, no Laplace transform, or those sophisticated method. Now I'm talking about basic integration method. So this is a very good example for those who are taking the first course of calculus. Now method 1. Now, when you see this kind of integral, you should have something in your mind. Okay, you need something that basic formulas. Well, you may consider this formula, right? 1 minus x squared, because this is equal to arcsine star, right? And so I create those kind of things. No? What is techniques of integration? That is the way I try to rearrange the integral function into something the basic formula can be used. So I have this, right? I have this 1 minus x. So in other words, my star is the square root x. If my star is the square root x, then I have a root x here, right? Then okay, this is dx. Now they're equal. I try to have this 1 minus square root of x square. This is my idea. So this must be square root of x to match this one, right? Now dx, d square root of x is equal to 1/2 root x, right? Well, you must be good in a derivative. We are looking for antiderivative. You must be good in derivative before you try antiderivative. So dx is this, right? I need a 2. So I don't have 2 here, so I'll multiply 2 here. Understand? So 2 is cancelled out, right? Yeah, then I have to multiply with 2 here. Then they are equal. No, this 2 is not. This 2 is there already. This one, including this 2, right? So I just multiply by 2 on top to balance with this equal sign. Then there's equal. So this one is equal to arcsine square root of x plus c. Yeah, finished. All right. That is method 1. Now method 2. This is dx. This is x 1 minus x. If I'm still using this idea, I must have something like this in a denominator. Now, x 1 minus x is equal to x minus x squared, right? Now I need a something square, so I have to complete the square. This one will be x minus half square, right? Negative. This will be equal to this. plus 1/4. I don't have a 1/4 here, so I take a 1/4 away. In other words, I have this in my mind. 1/4 minus x minus half square dx. Now equal. Okay, this one, this is in my mind. I have this. So it's not good enough. I need a 1 here. So before I take an equal sign, I can try anything, right? This is a 1/2. Now you have 1 here. I need a 1 minus something square. See, I have to maintain the equal sign. So this goes into the 1/4. 1/4. This becomes that. It has to be 2, right? 2 times x minus half. Yeah. Yeah, now there's equal. This is equal to this. Then my star, d star is d2x minus half. This is my d star. Yeah. So I have to balance with, because it's not equal. This is dx on top. Now becomes 2 dx. So it's multiplied by half. Now then equal. Okay, so the final result is, this is cancelled out, is arc sine 2x minus half plus c, right? So this one is the arc sine 2x plus 1. So that is my result. See, I'm using basic formula. Now method 1 have this. Method 2 have this. They're not the same. It doesn't matter because we're looking for antiderivative. What is the antiderivative? Antiderivative means the derivative of this is equal to my integrand function. If you take a derivative of this one, it is also equal to that. You know, therefore the antiderivative could be a different form. Okay, these are two methods which are different. Now method 3. Integral dx square root 1 minus x. Okay, this is my integral. Now, if I try by parts, see. Now, well, okay. Now let me see. I must have some basic idea to start. So, if I try this 1 plus d star, this is arctangent, right? Arctangent star plus c. Now, if I try this one for my integral, so I have to get rid of square root and create something square. Now, after several trials, several attempts, I let t be this x 1 minus x over x. I try this to be my new variable t. Then t square is equal to x square and x 1 minus x, right? from which we can find x is equal to 1 t squared plus 1. Why we need this? Because I have to replace the dx, for substitution, right? So dx is equal to t squared plus 1 square negative 2t, right? dt. Here I'm using substitution method, so I have to replace x by t at the same time that I replace dx, by t. So this is my I integral. My I will be equal to tx, right? dx. This one is equal to tx, right? tx. This is my denominator. My denominator is tx. My numerator is dx. dx becomes 2t dt and t squared plus 1 square. Yeah. Well, this is not good enough because I still have x. I must get rid of this x, right? So replace x by this. Minus 2t dt t times 1 over t squared plus 1 times t squared plus 1 square. So this one is equal to negative t cancel out. This one cancels out, is equal to negative 2 dt t squared plus 1 here. So this one is arctangent t plus c. Okay, that's good. So I put my t back. So this is negative 2 arctangent square root x 1 minus x over x plus c. That is my result for this integral by method 3. Now here the antiderivative is different from the first two methods. That doesn't matter because this one derivative with respect to x is my integrand function. Yeah, you may try. I just leave it for yourself to verify. Now this is method 3. Method 4. Well, method 4. This is in dx square root x 1 minus x. As I said in the beginning, I'm doing these integral today is trying to analyze, to come up with kind of a general idea. How do we treat the integral in general? So we have some kind of ideas, then we just work towards to that idea. So here, my idea is that I want to get rid of a square root. I want to get rid of a square root. So I may use substitution. So we'll let u be square root x 1 minus x. This might be the first method, or first idea across your mind, because just get rid of a square root. Then I must replace dx, by u, right? So here, u squared is equal to x 1 minus x. So this one is equal to x minus x squared. So x squared minus x plus u squared is equal to 1, is equal to 0. Then we can solve for x, right? X is equal to 2. The basic formula is 1 plus or minus the square root 1 minus 4 u squared. Good. Now then my dx is plus or minus this, right? This one is equal to 4 square root 1 minus 4u squared minus 8u du. You must be good in derivatives because we are doing antiderivatives, so you must be good before you doing antiderivative. Now this one is equal to plus or minus square root 1 minus 4u squared u du. Here I have a question. Which one? Plus or minus? Well, let me think this way. We are talking about this function, right? Square root x 1 minus x squared, 1 minus x, which is equal to x minus x squared. So x minus x squared must be positive or 0. Then this function, you have two intercepts, which is 0 and 1. So the function would look like this, positive, right? Positive. So in other words, my x is between 0 and 1. So it looks like my dx must be positive. Now, if you are not sure which one to take, doesn't matter. You calculate the result and then verify by taking derivatives. Choose the right one. Discard the one which is not correct, because when you're squaring both sides, sometimes you bring you a false root. Okay. Anyhow, we have this, right? We have this. We bring positive there. So this is I. My I is equal to square root. This is u, right? This is u. This is u on dx is this. Dx is du du, and the square root 1 minus 4u squared. Okay. Then this one is equal to square root 1 minus 2u, right? 2u squared, and d2u times half, they're equal. So this one is equal to half arcsine 2u plus c, and is equal to half arcsine, arcsine 2u, use this, right? 2 square root x 1 minus x plus c. So that is my result. So altogether, I have 4 methods to do this integral. So as I told you that my objective is to discuss in general how do we treat an integral, how do we start, what kind of basic idea of the method here for our integral. I'm here to talk about the basic integration, basic techniques of integration, not touching those sophisticated methods like Laplace transform, Cauchy residue, or Feynman's trick. Okay, thank you for your watching.